good. We learned yesterday when solving a quadratic equation. If I say to you, solve the quadratic equation, what are we finding? The x-intercept where it's crossing the x-axis. So that's why solving a quadratic is so huge. It's because we're finding the x-intercepts where it's crossing the x-axis. Can anyone remember what else we call them? X-intercepts or what? Zeros. That's another word. So good. Another word for x-intercepts are zeros. Another word, I don't think I said this yesterday. They're called roots as well. These are the roots. So just a couple things keep in mind. And these are also the solutions. So they all mean the same thing, just different words. So it says find the roots to the equation, you're simply solving it. Find the zeros to the equation, you're simply solving it. Find the solutions, you're solving it. Okay, so remember that quadratic equations will always have how many solutions? 2, always. Because remember, we learned the fundamental theorem of algebra says you look at the highest degree. So quadratics have the form ax squared plus bx plus c. And because our highest degree is 2, we will always have 2 solutions of some type. So when we have these type of solutions right here, what kind of solutions do we have? We have 2 what kind of solutions? 2 real solutions, because it's crossing the x-axis, and that's the real number line right here. So 2 real solutions. All right, so we learned that if the quadratic does not cross the x-axis, and there's no real solutions, but there's still a solution. There's 2 solutions still. What kind of solutions are they? Imaginary. Good, 2 imaginary solutions. Can anyone tell me when we were seeing yesterday imaginary solutions? When we had a what under the what? When we had an I, yeah, that made it imaginary. So my question, let me ask that again. We had 2 imaginary solutions when we had a what under the what? Anyone solve the puzzle? When do we see I's, guys? When we have a blank under the blank. A negative under the square root. Is everybody good with that? Right? Sorry, that was kind of unclear. I kind of made that up as I can. All right, so remember that we've done these 2 things. So this is what we learned yesterday. Now remember, we were solving quadratics when missing bx yesterday. So there's different methods. We're learning a different method today. Because if you have bx, you cannot use the method we learned yesterday. So remember, number 17 and number 20, this is from yesterday's worksheet. Let's quickly go through this here. So if we were to solve these, once again, notice we have ax squared plus c. We have no middle value bx, right? So we use the method we learned yesterday. So we isolate x squared, so we subtracted 28 from both sides. So we have 7x squared is equal to negative 28. Then we divide both sides by 7. So we have x squared is equal to negative 4. Then we took the square root of both sides of the equation. So our root cancels out with power. We get x is equal to plus and minus. We rewrote this as 4 times negative 1. What's the square root of 4? 2. What's the square root of negative 1? I. So we got x is equal to plus and minus 2i. Sorry. X is equal to plus and minus 2i. So those were our 2 solutions. No questions on that from yesterday. Yeah.
Can we do the plus and minus today?
We won't, it'll be different. It'll be completely different. So good question. Today there's going to be 2 solutions that aren't exact opposites of each other. All right, so looking at this one, same thing. We isolate x squared, so we add 49 to both sides. So we have 16x squared is equal to 49. Then we divided by 16. So we have x squared is equal to 49 over 16. Then we take the square root of both sides of the equation. Root cancels out with power. We get x is equal to plus and minus. Now remember, a lot of people kind of got stuck yesterday with something like this. We have a fraction. Is it a decimal? Yes. So you put it back in a fraction and split it up. So we're going to split it up. On top we have the square root of 49. On bottom we have the square root of 16. The square root of 49 is 7. The square root of 16 is 4. So we get x is equal to plus and minus 7/4. We have our 2 solutions. Any questions? Okay. So we're learning a new method today. Today we are solving quadratics by factoring. So So remember a while ago we learned how to factor quadratics. Well, the whole point, why did we learn how to factor quadratics? There was no point till now. The whole reason we learned to factor a quadratic is so that we can find the zeros, we can find the roots. So that's what we're learning today, is how to solve a quadratic by factoring. So you'll use this if the quadratic is factorable. So once again, notice, quadratics have the form, the standard form of ax squared plus bx plus c. Now understand something. Before we can factor, we have to make sure it's set equal to 0. That is the first rule. So if we have a quadratic, we can't start solving by factoring unless it's set equal to 0. So if we have a middle term bx, and we're going to have a middle term bx today, we can try solving by factoring. Now today on the worksheet, every quadratic I give you is going to be factorable. But in the future, there are quadratics that are not factorable, so you'll use a different method. You won't use factoring if it's not factorable. All right, so here are the step-by-step instructions on how to solve a quadratic by factoring. Now remember when we're solving, we're finding the x-intercepts. This is just another method to solving. So your first step is make sure the quadratic is set equal to 0. That is the most important thing. And make sure it's in standard form. So ax squared, the highest degree comes first, then bx, and c. Your second step is to factor out the greatest common factor if there is one. Now oftentimes with these there's not. So we always start by factoring the way we learned it. What multiplies to b, does everybody remember doing this? What multiplies to be a times c and adds up to be b. It's been a while, we'll go slow. What multiplies to be a times c and adds up to be b, you'll go through your drop and break, you'll factor it. So we will factor it clear down. Once we have it factored, we will have two linear factors being multiplied together. So we have two linear factors being multiplied. Now that whole quadratic was set equal to 0. Now remember, this is the factored form of the quadratic, this is the standard form of a quadratic. They're the exact same thing, they're equal, they're just in different forms. So if it was set equal to 0 up here, it's set equal to 0 down here. So we have those two things being multiplied set equal to 0. Now it's called the 0 for this third step. It's called the zero product property rule. And what the zero product property rule says is that you can split those two things that are being multiplied together here. You can split them up, set them each equal to 0, and solve for x algebraically. So once again, because these are being multiplied, and they're both set it's all set equal to 0, you can split it up, set them individually equal to 0, and solve for x. That's called the zero product property. So the reason I talk about the zero product property is because I've seen it on end of level tests, and in the instructions they'll say stuff like, use the zero product property rule, and if you don't know what that is, you're going to be like, wait, what is that? So this is what the zero product property rule is. It's saying you can split them up and set them each individually equal to 0 and solve. All right, are we ready to practice this? You have this down, you have a picture of it, however you want to have it. Now you're going to need paper. Like, these problems take a lot of work. So you're going to need paper. So you'll get out some scratch paper. Let's go through this piece by piece. Now once again, the first thing you have to do is make sure your quadratic is set equal to 0. Do not start factoring until your quadratic is set equal to 0. So looking at number 13 on the worksheet, we have w squared plus w is equal to 12, right? So what we're going to do is first say, okay, I'm solving the quadratic, I'm going to try factoring. Well, it's not equal to 0, so that's my first step. So this is positive 12. We're going to bring it over to this side of the equation, but it can't magically float over. We've got to make it equal to 0. So positive 12, we could subtract 12 from both sides of the equation. So over here on the left, w squared plus w minus 12. You can't combine any of that. So I have w squared plus w minus 12. Now notice I wrote it in standard form. Is everybody good with that? And now look over here on the right. What's 12 minus 12? Isn't that 0? So we've made it equal to 0 correctly here. And now we can begin solving by factoring. So once again, the first thing we do is just say, is there anything in common in these three terms that we'll factor out right now? No. So we continue with saying, okay, we're going to look for what multiplies to be a times c and adds up to be b. So I'm going over here. We're looking for what multiplies to be a times c and adds up to be b. So I'm going to list out real quick. My a value is in front of x squared or w squared, whatever. A is equal to 1. My b value is also equal to 1, and my c value is equal to negative 12. So now I can say what multiplies to be a times c. 1 times negative 12 is negative 12. So we're looking for what multiplies to be negative 12 and adds up to be b, which is 1. So I set it up like this so that I can go through and list some factors. Questions so far? We got to kind of go slow today. Okay, so what multiplies to be 12? 2 times 6, 3 times 4. Okay, let's figure out which ones would add up to be positive 1. Could 2 and 6 ever?
No.
No matter what, it couldn't. 3 and 4?
Yes.
It needs to be positive 1, so the negative needs to be with 3 or 4. Which one? 3. Now once again, check it because it has to work in both places. Is negative 3 times positive 4 negative 12?
Yes.
Yes. And then is negative 3 plus 4 equal to positive 1? Yes. So these are our two factors. So our factors are, and I'm just going to write them off to the side, negative 3 and positive 4. So I'm going to do this the long way to remind us how to do this, because this is actually quick factoring, right, everybody? Because our a value is 1. So those of you that like quick factoring, we know that this is going to factor to be w minus 3 times w plus 4. If you don't like quick factoring, everybody that likes quick factoring, raise your hand. Okay, awesome. So we know it's going to factor to be that. Now let's say you don't like quick factoring. Let's do this quickly the longer way. Because, and all of us have to know long factoring anyways, because there's times you can't use factoring. So those of you that like long factoring, that's great. Let's go through it. So you have your two factors. So you're going to drop and break. You drop down your n terms here. So you drop down w squared. You drop down negative 12. Then you break down your middle term, which means you're rewriting that middle term as these two factors. Don't forget your w with the two factors. The order doesn't matter, so I'm randomly saying minus 3w using that factor, and then positive 4w using that factor. Questions up to here. Then you group the first two terms. You group the second two terms, and then factor each group. So in this group, what's in common? W. So when I factored a w, I divided each term by w. So left here is w minus 3, right? Am I going too fast? Hopefully we remember factoring. Okay, in this group, what's in common?
4.
Positive 4. So we're pulling out positive 4. So we're dividing each thing by positive 4. So then left is w minus 3. W minus 3. Now you check your safe haven. Safe haven, it better be the same. And it is, so we factored this correctly. So we can pull out the safe haven. We pull out w minus 3. I'm struggling. We pull out w minus 3. And when we pulled it out, it divided out. So left was w plus 4. Now look, did this factor to be the same thing as our quick factoring? Yes. Okay. So now, the whole point of factoring is, well, wasn't our quadratic set equal to 0 up here?
Yes.
Yes. So it's still set equal to 0 down here. Because this is the same thing as this. This is just in factored form. So now that we factored this, we'll set it all equal to 0. Now it's the zero product property rule that says you can now set each of those things equal to 0. So you can split it up and set each of those equal to 0. So I'm going to go over here and say, okay, so I have w minus 3 is equal to 0. And I also have w plus 4 is equal to 0. Now solve for w algebraically in each case. So in this piece, we're going to add 3 to both sides, right? Add 3, add 3. So we have w is equal to 3. We're going to subtract 4, so we get w is equal to negative 4. And there's our two solutions to our quadratic equation. So that's why we learned factoring and how to factor a quadratic, is so that we could get to this day. Is everybody good with how to do that? Okay, I'm going to do one more off the worksheet, then I'm going to let you work. Here we go. So this one's going to take long factoring. I'm doing number 16, so give yourself some room to work through this with me. Please ask questions if you have. So first of all, it says solve by factoring. So we know it's going to be factorable. First thing you have to do is make sure it's set equal to 0. It's not. It's equal to negative 12. So we need to make that 0. So I'm going to add 12 to both sides. Now notice on the left, there's nothing we can combine here, nothing alike. So I'm going to just write it in standard form. 3j squared minus 20j and then plus 12. And that's equal to, if you add those up, it's 0. Make sure that you've done it correctly. So now we look and say, is there anything in common in all three terms we can factor out? No, right? Because 20 doesn't divide by 3. But if it did, you could factor out a 3. Okay, so now we're going to go ahead and continue. I'm going to write down what A is, which is 3. B is in front of J, so negative 20, and my C value is 12. Is anybody confused on where I got these? If so, I'll explain. Or are we all good at this point with those? Okay, so now we'll continue. We say we know how to factor a quadratic. What multiplies to be A times C and adds up to be B. So A times C, 3 times 12. What multiplies to be positive 36 and adds up to be negative 20. So now we're going to list out factors of 36. But I'm going to stop here and ask questions. Okay. So factors of 36. 1 times 36, 2 times 18. Let's look and see if either of those work. Could 1 and 36 add up to be negative 20? Could 2 and 18?
Yes.
Yes, but it needs to be negative 20, so when they both have to be negative. Now check it. Is negative 2 times negative 18 positive 36? Yes. And then also negative 2 plus negative 18 is negative 20. So it works in both cases. So our factors are negative 2 and negative 18. And now we have to drop and break because we cannot quick factor this because that A value is not 1. If you do quick factor it, you'll get it wrong, unfortunately. So let's drop and break. Here we go. So please ask questions if I need to slow down. So we drop down our n terms here exactly how they are. So we have 3j squared, we have positive 12. And now we're breaking down the middle term. We're rewriting that middle term as those two factors, but make sure because of the j, you put the j in. So order doesn't matter. So I'm randomly choosing negative 2j, and I'm randomly then putting negative 18j in. Questions up to here. Now we group the first two terms, and we group the second two terms. Make sure you group the sign with it. Okay, I'm going to push pause and ask questions. Okay, so then from here, we're going to focus on each group and factor out the greatest thing in common. So let's look at this group. What's the greatest thing in common? Just a j, so I pull out j. Now when you pulled it out, you divided each term by what you pulled out. So 3j squared divided by j is 3j left. Negative 2j's divided by j, negative 2. Questions on that? Then this next piece, we're factoring out the greatest thing in common. Now look, it needs to be a 3, right? 18 needs to become a 3. So this is just a little quick trick. So what is 18 divided by 3? 6. So we're going to try pulling out a 6, because it has to be, right, if it's factorable. So I'm going to pull out 6, but do you notice anything peculiar?
That's a negative.
Negative in front. If it has a negative in front, we always factor out a negative with our factor. So I'm going to try factoring out negative 6, because I know it needs to be 3. So I divide each term by negative 6. Let's see if this works. So negative 18 divided by negative 6. 3. So we have 3 j's in the front term, and then positive 12 divided by negative 6. Negative 2. Now check your safe haven. Is it the same? Yes, our safe haven's the same. So we can factor that safe haven out. So I'm going to factor out 3j minus 2. I factor it out. Now when I factored it out, it divided out. So left was j minus 6. Now these are linear factors, right, everybody? Linear means degree 1. Do you see how this 3j is degree 1? Do you see how this j is degree 1? So these are called linear factors. That's why they're called linear factors. So now we're down to our linear factors. Well, it's all equal to 0, so it's still equal to 0 down here. And now the zero product property rule says we can now split this up. Now that we have linear factors, we can split this up and and have them each equal to 0. So we have 3j minus 2 equal to 0, and we also have j minus 6 equal to 0. Now solve for j in each case. So I'm going to first up here add 2 to both sides of the equation, leaving me with 3j is equal to 2. Then we'll divide both sides by 3 to solve for j. So I have j is equal to 2/3. There's one of our answers. And then we're going to solve for j here. Add 6, so we get j is equal to 6. There's our second solution. You better have 2, or you've done it wrong, because quadratics always have 2 answers. Questions? Yes.
So why would they be 10 different? Because isn't j supposed to be equal to the exact same number?
So remember how yesterday we were dealing with ones that had no shift left and right. So if a quadratic shifted left and right, think about that happening. Then those x values won't be exact opposites of each other, would they? Those x-intercepts. Does that make sense? So parabolas can be shifted left and down, and then they might cross clear over on clear random points. Does that make sense? Good question. All right, so now I'm going to have you do 7 through 16. Advanced learners, you should be able to do 17 and 18. You should be able to factor those. So I want you to practice 7 through 18 right now. 7 through 16 right now. In a second, look up here in a second. Okay, so it says solve by factoring. Once again, the first thing we have to make sure is that it's set equal to 0. So I'm going to bring the 5b over. So I subtract 5b from both sides. Now remember, that's a d. So remember, you can't combine a d squared with a d, so we'll just write it in standard form. D squared minus 5d, and now is equal to 0, because those add up to be 0. Now, the two ladies that did this the hard way, which is fine. You can do it the hard way if you want. So the two ladies that did get it, they said, okay, so I'm going to show you, first of all, the way they did it. They said a is equal to 1, b is equal to -5, and c is equal to 0. Is that true? Yes, so then they did. What multiplies to be a times c, so what multiplies to be 0 and adds up to be -5. This is the harder way, but that's fine, like I said. So they said, okay, what multiplies to be 0 and adds up to be -5? 0 times -5. 0 times -5 is 0, and then 0 plus -5 is -5. So our factors are 0 and -5. Because of this a value being 1, we can quick factor it. So it's going to be a plus 0 times a minus 5. And then we set each of those equal to 0. So we'll set a plus 0 equal to 0. We'll set a minus 5 equal to 0. So a is equal to 0 and a is equal to 5. So that was the way hard way. Way hard way. So I'm going to go back and show you the way I think you should do it in the future. So, first thing, this is what they missed, and this will help them out and help you guys out in the future. Which, like I said, if you can do it that way, that's great. But look at how much easier this is. D squared minus 5d. Is there something in common right now that we can factor out? So I factor out a d. Left is d, so we divide each term by d. Left is d minus 5. Aren't those linear factors? Isn't that factored completely?
Yeah.
So we're done. Set each of those equal to 0. So this is a factor still, right? So we set d equal to 0. We set d minus 5 equal to 0. Solve for d in each case. Isn't d already solved for?
Yes.
There's one of our answers. Add 5. So d is equal to 5. So does everybody see how to do that one like the easiest way? Are we confused at all? Okay, awesome. So this is what's going to be due up to tomorrow. 7 through 16. Every one of those needs to be done. 7 through 16. And then we'll finish up some more tomorrow. So this obviously is going to take 2 days. So I need to see you finish out the last 15 minutes doing 7 through 16.